Hey, everybody, and welcome to The Index. I'm your host, Alex Kahaya, and today I'm excited to welcome Alexander Joseph Long, founder of Pluralis AI. Alexander is at the forefront of revolutionizing AI with decentralized training. It's a groundbreaking approach that promises to reshape the development and governance of foundation models, and something that is a bit of a contrarian viewpoint. Many people don't even think what he's trying to build is possible. So I'm very happy to have you on the show today. Thanks for being here.
Thanks for having me on.
So before we get into the impossible thing you're conquering, I'd just like to hear more about you, why you're in this space in the first place. Mind just telling your story a little bit here?
Yeah, sure. So I'm an AI guy. I did my PhD on non-parametric external memory in deep learning. I finished back in 2021, and then I joined Amazon straight out of that, where I was working on sort of multimodal foundation models there, and both publishing research and then also applying them into product internally and retail. So my background is sort of heavy on the tech side. I got really interested in sort of this whole area back in sort of the tail end of last year. And, you know, the thing is, when you start to really think this stuff through, when you start to really think what you need to get decentralized training to work, it's very obvious where a lot of crypto starts to fit in. And that was sort of what drew me across to this side. So I feel like I'm sort of just one of the first people that's coming from this sort of other world, and we're starting to sort of move across into this other field. And, you know, while there's a sort of small number of people doing it at the moment, I think it's gonna turn into quite a few soon.
So tell me more about, like, so you obviously have deep expertise in AI, and you've thought about this a lot. Why does decentralized training of AI matter? Why do people care about that?
Yeah.
Why should they care?
My view is very simple, right? If you cannot create the model, you have no way of enforcing any level of ownership or control. So if I'm taking a model that's been trained externally by some centralized group, you know, maybe it's Meta, maybe it's some other people who have done this sort of run where they've accumulated the compute themselves, and then you put the model into a protocol. My view is that you don't have any ability to control the behavior of that model, right? It's the people that made it that have the ability to control the behavior and also have the ability to sort of enforce ownership. And so for me, decentralized training is all about, if you want to have this world where you have some kind of a thriving open source, if you want to have this world where these things are actually democratically governed, you have to have some way of creating these things in a decentralized manner. It's not sufficient to create them centralized and then put them into a protocol after.
So I totally agree with you. And I want to break this down for people a little bit who might not be as familiar with like what goes into creating AI technology. There are several components here, right? There's data. There's a model. The model is like a piece of software that you can train with data and teach it to do things. And then that essentially, I like to think of it like a brain. It becomes a brain, like a toddler, and then it's a teenager, and it's got more data. The more data, the older it gets, the smarter it gets. And that brain goes somewhere, and it does what's called inference. And inference is you ask ChatGPT a question, and it infers the answer based off of the data it's been trained on. So am I missing anything here in the process? So that's like basically the full life cycle. And all of those things are being decentralized. But the big thing that, and I've heard this before this call from people, is the training piece. Training in a model in a decentralized manner isn't possible. Getting decentralized data is possible, and doing decentralized inference is possible. But there's been this like notion that the training piece is not possible. What about that is hard? Why do people say to you, no, this is never going to work?
I mean, there's a few sort of common reasons, right? The most common one is if you have this problem of these low bandwidth interconnects, right? This is if you tell any serious AI person, you're like, hey, we're going to do decentralized training, their first reaction will always be, okay, I understand why that would be very nice. You're never going to be able to do it because of the low bandwidth latency problem, right? And so what they're talking about there is like when you train a ChatGPT, like, you know, you do it in these big companies, it's on these massive data center racks. They have very, very fast interconnects, right? The data can move between the servers very, very fast. And because the models are so big, right, they're split across these accelerators. And the way distributed training works today is that, you have to sort of pass this data very, very frequently. You need to pass very large amounts of data, both in the forward pass and the backward pass. And, if you were to just take distributed training methods as they work today, and you were to switch out that substrate and you would say, okay, we're not using a data center with, NVLink and InfiniBand, we're going to do it on a sort of consumer grade swarm where everything's connected by the internet. It's just, you have this huge blow up, right? Everything has to wait for sort of the data to come. It's way, way slower. And so that's sort of the typical knee-jerk response is that makes this stuff infeasible.
Yeah, and I wish, and maybe I can talk to my producer about this after the show. We should get one of those, those whiteboard hand animated videos where they draw a diagram. We should do that for version A is centralized training. And you said distributed because it's the centralization piece it's Amazon or Chat or OpenAI training a data set on a model, using a data set to train a model. And they're doing it in this data center or a couple different data centers. But typically these servers need to be very close to each other because of the amount of data that has to get transferred between them. There's so much data here that you need a massive giant computer. You said the word swarm, and a swarm is like a huge computer. It's like leveraging 1,000 servers to work together to use this data. And the reason that works I'm just re-explaining it again so people can really grasp it. And this is kind of how I learned. The way it works is there's this thing called bandwidth, which is literally I like to think of it the size of the pipe that the data goes through. And the more bandwidth, the bigger the pipe is, the faster the connection and the more data that can go through that pipe and get trained on all these servers. Well, for my home computer, or even if I had a beefy server at my home, the pipes are pretty small. I'm sure everybody here has been why is my Zoom call so shitty right now? And it's because of bandwidth. There's just not enough bandwidth. And consumer grade bandwidth is typically shared. Actually, it's Cox Internet throttles your nightly Netflix viewing because everyone else is trying to watch Netflix at the same time. There just aren't big enough pipes. And so the consensus here is that for the massive, it's kind of hard to imagine, right? How big the clusters of computers are, and how much data is flowing through them to train something like GPT. You can't understate how massive an operation it is. It's literally thousands. The thing that I think is fascinating about it, I love one of my key passions in crypto has always been the idea of how do you bootstrap the physical infrastructure of a network? Because all these blockchains are literally bare metal. It's metal in a data center or or a computer at a house, but it's Meltem Demirors, who's a really well-known investor, she kind of coined this phrase where bits meet atoms. It really is where the bits meet the atoms. And it's physics. And so that piece of it is just really, really interesting to me. And so what you're trying to do is replicate what's possible in these data centers that are thousands of square feet, thousands of machines, thousands of bare metal servers doing the work. It's not trivial, right? It's not a trivial difference. The difference between that and consumers, 1,000 machines at your home, over 1,000 homes doing this kind of work is non-trivial. So how do you get around these problems? How do you solve this bandwidth issue and actually, because the GPUs are there, the compute power is there. If you can cluster a 1,000 or 100,000 people's computers, you can get the compute, but it's really the bandwidth, right? The compute's not actually the issue.
Yeah. And maybe just to drive that point home, right? Because you're exactly right. The distributed training, which is what I call the centralized training, right? It's so enormous. People have not grasped how enormous it is, right? So I read in the Llama technical paper, right? They're the ambient temperature changes and our power draw on the grid moves around by tens of megawatts. which is like, every now and then you read a sentence like that and it just puts it in perspective, right? Of like, this is just,
Yeah.
the scale of this is insanity,
Yeah.
right?
I keep trying to put visuals behind it so people can understand, because most people listening to this show don't see the infrastructure that actually makes this show even happen. Like me streaming this in like recording the show. I mean, I'm seeing a picture in my mind of like a huge, like what's a 10 megawatt producing solar farm, right? How many acres is that?
Yeah, I mean, it's larger. I mean, a good way of framing it is like, an average industrial city is probably like a gigawatt, right? So we're starting to talk about like just enormous scale, right? One of the most exciting things to me that's happening is like we're moving back into this era of heavy industry, right?
Mm-hmm.
Like we have these massive energy draws to create something that's like really tangibly useful, and and there's like huge amounts of physical build out. But I'll just say, so the distributed is enormous, right? But if you say you just take all of Facebook's GPU purchases for this year, right? Whatever they announced publicly, I think it was 350,000 H100s they're going to buy, right?
And that is insane.
It's enormous, right? H100 draws like 700 watts, right, at peak.
Yeah.
So very hand wavy. It's like all those things running at peak. It's probably about 200 megawatts, right? Somewhere around there. Which is like I said, right? Your whole city is probably about a gigawatt. But I'll tell you, like Bitcoin mining at peak was 20 gigawatts, right? So you have this enormous thing, which is gargantuan, but the scale of compute that's been assembled under these protocols has been already 2 magnitudes bigger, right? So that was one of the big things that sort of got me interested in this. When I did the very basic math on that, and I sort of saw the relative scales of these two things, quite frankly, I couldn't believe it, right? Like that's just enormous, right? So.
Yeah. I mean, the other opportunity, if you do the math on it, is Ethereum, right? Because they just moved from proof of work to proof of stake, but the proof of work was all GPU mining based, right? And so there's all these huge companies that started out mining Ethereum that are now repurposing their GPUs for AI, for that same reason. But the economic incentives of Ethereum are what created that physical infrastructure.
Yeah, it's very interesting, right? It's interesting that we ended up in this spot where, if you had to start from scratch today, there's no way you could do it, right? These things sort of led up to this scenario where it's vaguely feasible.
Okay, so walk me through how, like, I know you have like a blog post about this, but can you just walk us through how this actually works, like your solution to this problem? And then we can, after that, I want to get into the impacts, because we kind of led up to that a little bit. I think you can kind of think through some logical impacts of if you're able to do it decentralized versus this centralized heavy build out model. It can probably reduce the need to do such a massive build out in some ways. But can you just talk about the solution set? How does this work?
Yeah, so I think maybe it's important to sort of just contextualize it a bit, right? The lead up to this. So this stuff is all so raw still, right? Like you only had attention in 2017. You only had large scale runs happening in 2021 with GPT-3, GPT-4. A lot of the recent distributed training algorithms really are like a couple of years old, right? So the point I'm trying to make is that these things are sort of like, there's a recipe that people have stumbled on. They're optimizing it for the hardware that they have available, right? And it's all raw, right? This is not a stable, well-established field in how these things work today, right? And there's this element of, the algorithms are tailored for the hardware that was available, right? In a big company, you have these GPUs, these server racks. You have them for historical reasons, right? Originally, you would train these things with something called distributed data parallel, right? You needed these very high-speed node-to-node interconnects in that setting. Then the models got very big, and you have these, I have these very fast node-to-node interconnects. I can use them to train in an even more efficient way, right? But there's never been this sort of explicit focus on, well, what if I just optimize for communication efficiency? What if I'm not just trying to push, the actual performance profile of the model as far as I can get it with the hardware I have, but what if I really motivated by getting this thing to work in the swarm setting and I just optimize for that, how can I do that, right? That's not something that's happened in the literature. And we're just starting to see that occur now. It's the beginning of the research there. Because people have become aware that this is a very sort of, if you can get this to work, it sort of potentially avoids a lot of problems, right? So that's the whole setting. Is like, it's not as if, I'm saying that I've figured out some key technical breakthrough that I've like figured out in my house by myself, just thinking about it, right? The framing of the situation is that there's this obvious research direction. The initial results in this research direction strongly point towards feasibility, in my view, rather than infeasibility. There's like early serious research here already demonstrating, okay, we can do like a 1 billion parameter run over these low bandwidth interconnects, which we can talk about if you want. And so the vector of progress here to me is like, why would we not try and do this, right? Why would we not try and why isn't there more people actually just focusing on this exact problem? And that's sort of what I'm trying to do with Pluralis.
And so can you tell me more about like how would it work in theory, right? Like it sounds like some of this is still theoretical. So how do you, so just to recap to make sure I understood, today people are optimizing their models to run on hardware and be like as efficient as possible there with the like the rate limiter being how much data can you pump into this model? That's the optimization. It's like amount of data I can send here. The thing they're not doing is optimizing for the communication between those servers.
Yeah, and the point is if you're in FANG, you have the very efficient cluster. You don't need to optimize for that, right?
What's FANG?
Like a big tech, Amazon, or if you're in one of these industrial research.
Oh yeah, you're one of these big, yeah. You don't need to optimize for it because you just have so much money. You can just
servers.
Yeah, you can just buy all the servers.
You have this known recipe. There's no risk. You just we know we can speed up these interconnects. We know what makes the algorithm slightly faster. We don't need. Yeah,
let's talk about that a little bit because I feel like we kind of glossed over this a little bit. I mean, you talked about it in the beginning, but the real problem here is that the AI is the most powerful technology that humanity will ever see, probably. I think that's fair. It's one of the most. And right now, a handful of companies, might be 5, have and are accumulating all of the compute power necessary to power AI. And it's a huge moat. It's a big barrier to entry. The real thing that they own, by the way, the model is just one piece. And this is something you said, you articulated this in the beginning as well. Like the model is just one piece. It's the data combined with the model that makes that brain that is the AI that you can own. And that brain lives on infrastructure and it's trained on infrastructure. And so you really, right now, today, the only way to get that, and that's immense power. If you own that, it's immense power. And it's not, I think like people think about it as like IP, where you have like a closed source model. You don't need a closed source model like to own it. You need the hardware and the data. If you have those two things and you have the skills to train it, then you own the thing. And I think this is for enterprise, especially. They kind of, some of them realize it, but I think a lot of people probably don't. When they're like giving their data to train an AI for use in their company, they're giving away ownership of that AI. They don't own it. And anyway, so the solution set that you're talking about, enabling this decentralized training paired with ownership of data means that you can own, or the community can own, the AI instead of this company. And anybody, and it lowers the barrier to access to creating this, what is essentially like almost like a natural resource, if you think about it. Like, and so it's a, I guess I say all that to point out to everybody how serious a problem it is. Like, it's kind of existential. To me, it seems existential. There's existential risk not having another option, right? Like having what is essentially like, I think the equivalent of nuclear weapons is like a pretty good, a pretty, like, maybe it's not that apocalyptic, but the amount of power individual company can have, it's like almost like owning a nuke. So
yeah, I think you articulated that really well, right? This was one of the main motivators of me trying to do this. Is I don't think this awareness was there sort of towards the end of last year that these things would obviously trend towards oligopoly. That there was sort of natural dynamics of, you have these huge capital costs for training that sort of tended these things towards oligopoly. I think it's much clearer now that that's sort of what's going to happen. And I think it's also very clear why, I think the right analogy is sort of like a commodity, except it's a commodity that injects its sort of cultural bias into everything it touches. It's like, imagine oil that injected politics in every machine it went into, right? That's sort of what we're talking about. And we have this natural dynamic here that pushes these things toward Standard Oil 2.0, right? There's really going to be one or two giant corporations that are going to be the base model providers. They're going to capture most of the value, and they're going to decide how these things behave, right? And as of today, I don't think there's an alternative. I don't think traditional open source, the way it's set up today, people are talking about, oh, well, it's okay, we're going to have this thriving open source ecosystem that's going to challenge this oligopoly. I don't see how that happens when these runs end up costing hundreds of millions to billions of dollars, right? I think you have this key difference where traditional open source is people donating their time, and people are acting as if people are going to donate money, right?
Yeah.
Which is what you need to get these training runs to work. And in my view, that's not going to happen.
No. You really need token economics to get to the scale, right? You need tokens and technology that powers decentralized training. It occurs to me when you're saying this too, that like on this show, we've had two of the dark horses of AI come on. This is one of them. The idea that decentralized training is possible. The other one was Peter Voss, who came on. He's the founder of I think it's called Agoya AI. I'd have to go look at my notes from that one, but he and two other guys were the co-authors of a book about AGI. They like coined the term AGI back in like the early 2000s, and what he works on is called cognitive AI. Versus like LLM based models, you have to train them, then put them into a server for inference. This one like learns on the fly. I don't know if you're familiar with this, but like they like the reason, and he's got a company with like 30 employees. They have customers. They use this AI at enterprise and it works. But because it can train on the fly, it requires way less compute. And I think we've like landed on the two. His is closed source though, but he I think he would be open or could be convinced to open sourcing it, which would be huge under the right circumstances. Because it's like, I think these two ideas are very important to preventing the outcome that we're both seeing already happen around us. Anyway, this is more of like just an observation from me, like some things that I'm seeing. Like there's these like dark horses that nobody's talking about. And a large part of why both of these things haven't been talked about is because of the consensus. Like engineers learn, it's like the hammer and the nail thing, right? They have a hammer that they can hit a nail with, and they're all taught to use that same hammer. And that's where all the money ends up flowing. I actually don't think it's because no one thinks these things. I mean, they do think that they might not work or that they won't work, but it's also just as much like, the analogy I give to people is with like GIS software. Like Esri is the main geospatial information system software provider. And they did a great job at all the universities getting all the GIS professors licenses to this. And so they train all their students. And so this is just the hammer that like everybody has to use. And I think for whatever reason, like LLM based training kind of became the hammer as well. And same thing with like the centralized training piece is there because obviously it's just like harder to do decentralized. But before I keep rambling, can you break down actually though for me a little bit, like how this is possible? Like maybe it's in the blog article. Can you explain to us what's in that?
Yeah, I mean, so I mentioned you have this low bandwidth problem, but you have even bigger problems, right? Like if you have heterogeneous node capacity on the memory, as well as the compute, you don't have that in the centralized case. If you have nodes entering and dropping, you actually do have that happen in the decentralized case. In the centralized case, just because when you do it at the scale, like things break, and so you actually have some level of time. But you have it at a much larger scale in this sort of swarm setting. And you also have this problem like in a centralized case, you know that the gradient you're getting is right. If you're doing this with individuals,
what's the gradient?
Some way to like gradient is, you can think about it as like one fraction of that piece of information from the data you're training on that you're sort of making the model a little step better. And so you're applying these gradients repeatedly, and like you said at the start, you converge on a useful model, right?
Okay.
Gradient is like the information that makes the thing slightly better.
Got it.
Yeah, so you have a lot of problems, right? Is sort of what I'm saying. The core of it is this low bandwidth, though, right? And there's a range of sort of solutions here. There's sort of the first sort of set of ways is, okay, let's take the distributed approaches we have today, right? And let's focus on the sort of communication primitives and what's actually being moved around. And let's just max out the compression, right? Let's try and think about ways we can maybe make this slightly more efficient. But the sort of general idea is like, let's adapt the distributed training approaches today and just focus them with this explicit objective of making them communication efficient, right? My view is you can get a reasonably long way with this kind of thing. And like I said, there's actually a work swarm parallel. It's demonstrated you can do this in a setting called pipeline parallel up to about a 1 billion parameter model, right? And it wasn't the limit, right? It's not, I think you probably push a bit farther. It's not clear, right? But that approach is not going to scale to, 100 billion, 1 trillion, or 10 trillion parameter models, right? There's a whole other direction, which is you have these things called asynchronous updates. So if I step back from maybe just to give a bit more context, like when you train the model, there's this information flow through the network. It goes through on a forward pass, you calculate a loss, you then pass the information back, you update all of your little parameters. Parameters are sort of the actual thing that makes up the model with those gradients that you've calculated from your loss, right? And you have to do this all in lockstep, and you have to make sure that like the gradient you calculated from your loss is being applied to each little part of your model in the correct way. And then, you do that process, the information flows back, and then you do it again, and you just repeat this over and over again. But there's this whole line of work, which is actually quite old, which is, well, what if I just start continuously pushing data through and I don't wait for the model, for the gradient to come back? I just push through, I activate, and whenever I get my gradient back, I just update my parameter, right? And it introduces a big problem of like, suddenly parts of your model might be out of sync with other parts, right? So it introduces that problem, but it solves another problem, which means you don't have to wait, which is one of the reasons why this sort of communication efficiency is such an issue. So there's sort of very, very early work there on people applying this async training method to decentralized training. I think that has a lot of legs, right? It's sort of this like intermediate approach between, okay, the low risk, we just adapt the standard distributed training, and the sort of third class of approaches that I think, which is like, you start to look at alternative architectures where, sort of like you mentioned, I think someone was doing something different. There's sort of a few guys now that are like, well, we don't think there's anything that special about transformers. We think there's something fundamental there, but it can probably be replicated in another type of architecture. I think that's sort of, if I rank those things in sort of range of like risk to payoff, I think the new architectures are very speculative, right? It's going to be a lot of work to get something like that to work and match GPT level performance, but I think it's absolutely worth trying. And in the meantime, I think there's sort of these two intermediate ways, which are much lower risk and can also get quite a long way.
So that's a good segue into my next question, which is like, how do you go to market here? Because, crypto moves really fast. The market moves really quickly. The need is great. And I think my hypothesis is the customers feel the pain, right? Like there's people out there who wish they could train their own models at the scale that like Facebook does, but they can't. They don't have access to those resources. The open source models exist. That's the one plus about Facebook. They do make a lot of open source models that are good. But the infrastructure to train them on does not exist at scale. Really it does exist at scale. It's the access and the efficiency to do it, the technology to actually make that feasible. So, and one thing I found in crypto is like, I think in most technology new startups, if you're doing something really hard, there's this balance between like hardcore R&D and solving these technical problems and practical business strategy and execution, like shipping something and getting it to market. I've seen teams raise like tens of millions of dollars and end up shipping nothing because they sit in a room trying to solve all these problems all the time that are, they're solvable over time, but like you have to build something that you can then fund indefinitely off of revenue or whatever. So how do you think about that? Like, what's your plan? I know it's super early. You're in like this research phase kind of still. It's pre-seed with this idea, but like, how are you planning on like actually taking something initial to market? Like, what's the MVP, I guess, is like another way of putting the question in a much shorter fashion.
So like I said, right, you can sort of train these things decentralized today at small scales, right? So you don't have a GPT-4 capable model, but you can train a sort of 1 billion parameter thing today in this way, right? Which, by the way, is like not a well-known thing. When I tell my AI friends this, they go, "What? Like I can do that?" And then I show them the paper, and they go, "Oh, okay, I didn't know that," you know. So, and my view is there's a large amount of sort of narrow value capture that happens at those model scales, right? So, I think there's a lot of reasons why having sort of a decentralized swarm where you can train small models that maybe aren't as broadly useful as a big GPT-4, but
they're point specific. They're point specific, right? It's not like a general purpose tool, but you can scope it to something and it'll be useful.
That's right. That's exactly right. Right. And the whole point is if you will do this in this decentralized way, even though those runs aren't particularly expensive, you don't have this sort of massive upfront capital cost. If you have some kind of an active swarm where you're sort of only returning, you're paying for the thing in fractional ownership, right? If someone contributes their compute to that model, they have some sort of, small fractional ownership. And it means that you get that permissionless dynamic that characterizes open source at the model development layer, right? I don't need to accumulate a big capital pool to initiate a model run. If I'm a model designer, all I need to do, is make a clear case that this model is potentially useful to somebody. And there's this, direct incentive for a compute provider to actually participate in that run, right? Because they're going to get reimbursed from use. So
what about the data? Where do you get the data for this situation?
I think for these small models, you don't run into this problem of really massive data until you start getting up around GPT-4, right? Like today, you can use FineWeb, there's sort of various other big curated centralized data sets. You get a very long way with those, right?
Yeah.
If you have sort of proprietary data that you want to inject in the model, I think there's a lot of obvious ways you can do that. You can set up like as a RAG-like setup, or you can put in the fine tuning. To me, that's not the main focus of what I'm trying to do. I think there's sort of clear, obvious solutions there in a way that there's not clear, obvious solutions to getting the decentralized training to work today. But when you start to get up among the big scales, that's when I think the proprietary data becomes much more critical.
Yep. But that's the vision for you eventually, is to get that big. And it's interesting because I know Jake, Berkman over at CoinFund is invested in you, and he's also an investor in Bagel. I don't know if you know the Bagel Network guys.
I do.
But yeah, they're, so Bidon is a friend. I'm an advisor to Bagel now. And they're doing some really cool tech on the privacy side, which would directly apply here. And I think either is open source or will all be open sourced. I wonder, have you talked to him? Have you had a conversation with him?
I have. I do know Biden, actually.
So I'm wondering what his thoughts were, because I think he's one of the people that talked to me about decentralized training. That like, did he think it was possible? I can't remember what his first reaction was.
I don't remember him having a strong negative reaction, but maybe he was just being nice to me.
Yeah, interesting. I'll have to ask him. I owe him a check-in. So it sounds like your go-to-market is like this paper kind of says, hey, it is possible to train these billion parameter models, which is useful. And so you're going to take that paper and actually try to build that as a protocol.
That's exactly right. Right. We want to start by implementing here's a proof of concept that small to medium-sized models can be trained in this way, right? Because that's still an extremely contrarian position, right?
Yeah.
I want to be clear about that. Like, most people do not agree with what I'm saying there. So we want to demonstrate that. We think there's sort of clear ways we can get narrow utility in that setting, and we're going to build from there into the much, much bigger ones.
So What do you need what help can people listening give you? How can they contribute, if at all? What do you need?
I mean, today we're still just focused on that core technical problem. So we're still a little ways from sort of an active product or marketplace or a token here. I think the main thing we're really interested in is if there are research scientists listening to this, particularly people in FANG or in these big labs, and they're maybe not entirely on board with the direction that the model governance is going. We really want people active in the protocol that are actually doing model design, right? To me, that's actually the main constraint, is that expertise to actually develop these models, to understand some of the training dynamics, which as of today is still a lot more of an art than a science. Come and get in touch. We'd love to sort of get you involved in some of this stuff while it's still internal only, and go from there.
I know a few people you should talk to. We'll make some intros at the end after we get off.
That'd be awesome.
What have I not asked you that I should have asked?
I mean, we sort of brushed over it, but I think a big topic is just sort of why this decentralization is critical, why the centralization is so bad, right? Because I think there's an emerging understanding of why it's bad, but it's maybe not precise, right? And also just the natural fact that this thing does lend itself to centralization, right? So I don't know, I'll just paint a picture of one of my main concerns, right? Which is, let's just say this stuff ends up becoming very useful as a tutor, right? So, which to me, it seems like it obviously would. If I want to learn something and I have the system I can interact with, which is like personalized and contextual, and it sort of also knows what else I struggle with, and it can really guide me, right? And this ends up being one of the common ways that most people learn most things, right? Like I'm talking about when you're young, you're going through school, you're interacting with these AI tutors very often. That to me seems very likely. And if you combine that with this scenario of an oligopoly, right? What you end up happening is like you have a very small group of people basically shaping the worldview of entire generations of people, right? And I don't see this risk discussed at all. This particular thing of like, you potentially have this world where every book, every internet article, every encyclopedia that you could access, if the LLMs are the base knowledge source, a very small handful of people write all those things. It's like they were all written by the same person. And maybe they go through different providers, and maybe there's one, software vendor that's calling, one model provider, another one using the other one. But the point is the base knowledge source sort of becomes totally centralized and the same. And because these things, it doesn't matter how much you try to debias them or do safety or whatever, these things are inherently political. They inherently possess cultural values because they have to give an answer on subjective questions. I think that's really, really dangerous, right?
It's Orwellian.
It's
terrifying.
I think it's far more dangerous than the common safety risk of, maybe someone uses this thing to make a bioweapon, right? Like, I think that's a danger. I think this concentration of power is much, much worse. And the point I'm trying to make is that today we're on the glide path to that. If things don't change, if we don't have some kind of a real, genuine, decentralized alternative where these things are actually being created and not just taken and put in a protocol later, the only other path is heavy regulation, right?
Yeah.
And
when we've seen in real time how that doesn't work. There's a great example from Web 2.0 from the last 10 years, and that's social media. TikTok.
That's right.
TikTok is used by every young American. I'm 38. I don't use TikTok, but I don't use TikTok because of the privacy reasons, because I'm aware of what's going on there. But it is controlled by a foreign government who actively, uses it to manipulate the populace. And this is the same thing, even though it's just owned by corporations. Maybe they're foreign or not, but it happens. If you talk about regulation, right? You're not going to regulate fast enough. Number one, the regulations are going to probably be terrible, and you're not going to regulate fast enough. Before you know it, half the population or the entire, look at ChatGPT, 100 million users in like what, 3 months, something like that from when they launched. It's the fastest growing piece of technology ever. And so you're just never going to keep up. So
yeah, I think that's exactly right. I have major doubts that regulation here can be effective. And I also just want to say, like, I don't think the individuals in these companies are bad people. You know, I know these people are genuinely very, very smart, very high integrity, are genuinely trying to do the right thing. There is just something about corporations which lead to these perverse outcomes, even when every individual inside of them is sort of well-intentioned, right? And this is my big concern, that even though, you know, I got friends that are making these models that I know they're trying to do the right thing. I just think there's structure that sort of leads to this emergent behavior, which overall is very, very negative. And that's my main concern.
I couldn't agree more. And I think it's great, the work that you're doing. I hope it succeeds. And I think it's very important that we have another option, right? Like a different alternative. And right now we don't. So with that, we'll wrap. Thanks for coming on. And if you're listening to this and you want an intro to Alexander, you know, my DMs are open. Where can they reach you online? Like Twitter or? Yeah,
I'm active on Twitter, Alexander J. Long. That's probably the best place to reach me there.
Cool. All right. Well, you guys heard it here first. Thanks so much for being here.
Thanks for having me.